My guest today on the podcast is Ed Bernardon. He's the VP of Strategic Automotive Initiatives at Siemens, the largest industrial manufacturing company in Europe at a $77 billion a year company. He holds a Master of Science in Mechanical Engineering from MIT, a BS in Mechanical Engineering from Purdue, and an MBA from Butler. He was one of the founding members of Vistagy, a company whose coolest application was building a bunch of carbon fiber parts for a few Formula One teams, the company eventually being bought out by Siemens in 2011. He is responsible for transportation and automotive thought leadership at Siemens, and he is the host of the Future Car podcast. Enjoy. Good. So you're a racer. That's great. We've got some common ground.
Yeah, absolutely. I've never talked to a NASCAR star before.
Well, Canadian. So it's funny, we do 5 or 6 road courses of the 12 race season. So it's we've got a lot of ex IndyCar guys and stuff like that. So it's an awesome mix, and we've got the cars working pretty well on the road courses. And I mean, that's the way NASCAR down in the States is going too. They seem to add a road course every single year.
What's the split now? I don't even know what's the split for you? Road course versus oval?
Yeah, we do courses and 7 ovals.
Oh, wow. Almost 50-50 then.
Yeah, it's good. It's good. And for a guy growing up racing go-karts like myself, like road course stuff, it's makes the series accessible, and then you kind of learn your way as you as you just get thrown into the little ovals.
Yeah. Well, I grew up in Indianapolis, so I just thought everyone always raced on ovals, right? And but how do you compare road course to racing on oval? I've never myself raced on an oval. I mean, like Lime Rock has sort of an oval on one end. One of the turns is somewhat like an oval, but I've never actually raced on one. Do you like one better than the other?
I do like the road course racing better. It's a completely different sport. It's like I kind of equate it for my friends who golf. It's like having to hit a perfect golf shot at, again and again and again and again without a break as far as going through the corners, whereas the road course, you can kind of take a couple deep breaths and it's more like proper golf.
Yeah.
Well, if you're good, we'll just jump right in. I want if you don't mind to give my guests a little bit of your bio and kind of what you do day to day.
All right, sounds good. Let me just jump right in then.
Yeah, absolutely.
Well, my name's Ed Bernardon, and I'm out of the Boston area, and I currently work for Siemens. I was actually part of a startup that Siemens acquired almost 10 years ago now. Siemens is a large company. They do all sorts of things, like 350,000 people, anything, trains, MRI machines, factory robots. There's all sorts of things like that. And I'm in the division that does engineering software. And the startup that myself and 3 others founded was software for designing with carbon fiber. And we figured out a way that if you had a shape in 3 dimensions and the carbon fiber comes off the roll, we could figure out the shape you had to do in 2 dimensions, so that you laid it up, the carbon fiber would fit just right, and you'd know where all the fibers were pointing and all that kind of thing. And so as part of that company, we grew it to about 80 people by the time we were acquired. But I got to know a lot of the Formula One teams, because carbon fiber is really, really big in Formula One, and then aerospace, obviously fighter planes and things like that. And since I've joined Siemens, they've let us, I guess you could say, we do a lot of special projects. I work on projects that combine things from different divisions. So our division is the engineering software one, but I work with the mobility division that does a lot of things with connected vehicles, or Siemens Energy does things in hydrogen and fuel cells, that kind of thing. And but mostly my projects are related to autonomous cars, electric cars, and we do a lot of work actually with the FIA. We had a project with them that we completed a couple of years back, putting autonomous car sensors in rally cars that detect all those crazy spectators that jump out in front of the car. So we're continuing to do some projects with them as well.
Wow. Okay. So how did you get into fiber manufacturing? How did that company come about?
Well, that's actually a really interesting story. Well, coming out of grad school, I had studied robotics, control systems, things like that, and the Draper Laboratory, which is in Cambridge, Mass, was right across the street from MIT. So I ended up getting a job there. And the Draper Laboratory is known for putting guidance systems in missiles, right? That they invented. I guess they invented these very high precision guidance systems, like for the lunar lander, all sorts of things like that. And they decide they're going to get into the commercial business, and they started a group to make robots to manufacture clothes. And so that's where we got started. And most of the people that were working on the guidance systems weren't too interested in that. So it was mostly a lot of younger people just out of grad school. And we created or generated a lot of expertise, developed expertise in manipulating flexible materials with robots. And then we figured out, hey, we could use all this technology to move fabrics of carbon fiber around. And the aerospace industry has a lot more money than the textile and apparel industry. So we started doing work with building machines, and machines for manufacturing carbon fiber. So taking rolls of carbon fiber and shaping it. So some of them were forming machines, all sorts of things like that. Anyways, when we were building these machines, we said, God, if only we could figure out the shape of the material before we shape it. And we actually wrote a crude version of the software. And then it turned out all our customers that wanted machines were more interested in this software. And that's how it all got started. We said, hey, we could start a business doing this. And so now we're looking for companies that are using carbon fiber. And usually, if you look at the cost per pound of something, like a fighter plane or Formula One car, or even a golf club, cost per pound is really, really high. And so if you want performance and you're willing to pay, those were our customers. And so primarily it was aerospace at first, companies like Boeing and Northrop, those types of companies. But when we finally decided to take our business to Europe, we went to the UK because they speak for us the same language. So that made it a little easier. And on the very first trip over there, I went to Benetton Formula One. It was the first time I'd ever been in a Formula One factory. And they became our first customer in Formula One. And from that, we grew it to many others. And to this day, because Benetton became Lotus, and it became Renault. Now it's Alpine. And we've known those guys, and still to this day work with them. And they've actually become really, really good friends. But as you know, Formula One is, from a technology standpoint, anything that can help them move faster in design. And when it comes to carbon fiber, they're certainly knowing the shape and being able to lay it up without wrinkles. Because if you have wrinkles in the carbon fiber, then it won't be as strong. It won't have the stiffness and the strength and the direction that you want. And we were able to predict that. So it made the structures more they were able to predict the performance better, especially on safety structures, right? Like for side impact and nose and things like that. So we were able to speed up their ability to design a car. And when you go from week to week, you got 2 weeks between a race, you want to redesign something, anything that buys you hours or a day is worth a lot. So, and that's how we got into carbon fiber, from learning how to manipulate fabrics that went into blue jeans and suits and things like that. So a lot of commonality between, I guess, blue jeans and Formula One cars in some ways, at least.
Wow. Very, very technical industry or technical business that turned out to kind of have some pretty sexy applications, I guess. So when did you guys get bought out by Siemens? And I guess maybe give us a little bit of a background on the history of Siemens. It's a pretty old company.
Yes, we were purchased by Siemens in at the end of 2011, so early, you can almost say at the beginning of 2012. And yes, you're right. Siemens was founded in 1847. I forget what the first invention was, but it grew over time. It's a German company, and it's grown over time now with many, many different divisions. And especially when you're in Europe, and certainly when you're in Germany, it seems like every time you turn around, you see a Siemens building, because they are in so many different types of industries. So our industry is called Digital Industries. This is our division, and it's mostly related to factories, and in one part hardware for factories like machine controllers, things like that. There's also an engineering division with that, and that's used by aerospace companies, automotive companies, anyone that wants to engineer things like electric cars or autonomous cars, or pretty much anything. So we're in a lot of industries there. There's other divisions, mobility division that does things like trains, connected vehicles. We have a Healthineers division, which is healthcare devices like MRI machines, those kinds of things. So it's a lot of different technology. A lot of times Siemens will invent things and then get out of the business. I know they were one of the first into cell phones for a while, and appliances. They did that for a while and got out of that. So it was a big change going from 80 people to 350,000. There's some challenges, and certainly it's nice when you go to a big company because you don't have to worry about resources. But then, of course, it's doesn't have all the freedom sometimes that you have in a startup to quickly move, because you have a lot more people that you have to coordinate with.
Sure. So what are you working on there kind of day to day now? I see on kind of cruising the internet, you do a lot of talking about electric cars and autonomous cars and, I don't know, Philip K. Dick stuff, futuristic stuff.
Well, if you think about what's happening in the automotive industry now, and that's really my focus, is primarily the automotive industry, and coming from the division that works on engineering software, there's some big challenges that are occurring right now in how cars are engineered. So if you think about it, from the days of the Model T to, say, before electric cars and autonomous cars came around, for the most part, there's been changes in materials and certainly improvements in powertrains and all that. But for the most part, it's a gasoline engine driving a car made out of steel and more recently aluminum. And the configuration, first it was rear-wheel drive, then front-wheel drive. But the people the engineers that worked on the car body, right, sort of had a pretty rough understanding, or a good enough understanding, of how the powertrain would be fitted in there. And there's a lot of history, so that the powertrain and the body people could probably work together much more easily, or with less communication, than when suddenly, now we're going to have batteries and electric motors and no gas tank anymore, but now we got these big heavy batteries. And within each of the systems, and you can think about batteries, right? Because there's battery chemistry. That chemistry is in a cell. The cells are put into modules. The modules are put into battery packs. And there's this drive, right, to have more range. And that means more batteries, which means more volume and more weight. So now you've got this big, heavy battery pack. And you say, hey, car body guys, stick this into your car. Now, to the car body people, you've got this, you might have like a B-pillar or some component, right, that you've worked with for a long, long time. But now suddenly you've got this component that is the floor of the vehicle, is very, very heavy. It's taking up a lot more room. You got to figure out how to package this in and make sure the car, because of the extra weight, doesn't twist or bend or rattle. And now, since the floor might raise up a little bit, you got to still fit the seats in, on and on and on. And since it's in its early stages, and I say early, only 5 or 10 years of experience versus 80, the body engineers might not know all the intricacies of what goes on the other side with the battery systems and all that, and vice versa. So what I end up working on, and the people that I work with, is developing engineering tools that help the engineers actually speed up how they can come up with a design that's really going to work, right? Well, I want to achieve the range that we need, but we have to do it in a vehicle that's comfortable, that doesn't rattle around, that's lightweight enough to get the range that you need, et cetera. And it requires a lot of back and forth between all these different groups. And one of the things we talk about is this thing called a digital twin, which is create a, not just geometrically, what the car and the batteries and all that look like, but the geometry plus all its physics that's behind it. It's a physics from an electrical standpoint, a mechanical standpoint, a thermal standpoint, all that. So you can pretty much design the car virtually. And then once you test it physically, there's a much, much greater chance it's going to work. So a lot of pieces to all that, but more or less, those are the types of projects that I work on.
Right. So it's gone from a fairly separate endeavor, building a car where, like, the Ford's assembly line type deal, to now a technology heavy, holistic way of building a car and making sure everything kind of works together, and leaning on different departments to help alleviate some of the issues created by the electrification or the batteries or whatever it is.
Yeah, you're absolutely right. And it's not to say that previously you didn't need that cooperation, because you always do, right? Even if you have an internal combustion engine. However, it's interesting, right? As say you're I'm a mechanical engineer. So as a mechanical engineer, or like you say, if you're a racer or whatever, you can sort of understand if you stiffen the spring, you can see it. It's like right there. Well, now you got these guys working with chemistry and this and that, and they want more volume. It's in some ways it's like two different cultures, right, that start to come together. So you still have to have that communication and concurrent design, if you want to call it that, right, where you design everything at the same time. But you do add another level of complexity because of the changes that are happening in cars now. And I think people are also becoming more demanding. Right, you're expecting more features, and the cars are connected, and then there's infrastructure. There's all sorts of things that go beyond just the mechanical aspects of the car that relate to the electronics or the software or being connected, right? The car actually being online. In some ways becoming more of like a cell phone, say, right, like a smartphone on wheels that you're inside of.
Right. So you guys have to be growing at a pretty staggering rate now with the, call it the top down push in most governments to electrify, whatever timeline it is, all vehicles by 2035 or 2040, or depending on what state or country you're in. Is it in your eyes, is it a lot of that top down push, or do you think that the consumer is really driving the demand for electric cars?
That's a great question. Well, there's so many reasons why you might want to buy an electric car. And certainly there's a sustainability aspect of it. And a lot of people talk about that. And sometimes that can even get a little bit political, right? Where people are for them or against them. But if we can put that aside and think about electric drive for a second, slightly different than a pure battery electric vehicle, but electric drive, where you have, and listen, this in its simplest form, you could take a wheel motor, and a wheel motor would be a motor that's actually inside the wheel, right? And you put 4 of those in the corners, and then you have some electronics to drive those. I'm really simplifying it quite a bit. But if you compare that to internal combustion engine, you've got 4 moving parts, right, actually. And with that, you can do a lot of things. You can drive the wheels. You actually do braking with regenerative power by running those motors like generators. there's no oil. I remember there's actually a video online. It's really an interesting video where a mechanic shows all the parts on the 10,000 mile, maintenance. And you've got, oil filter and dirty oil. And of course, his hands are all dirty from doing that. And then on the electric side, there wasn't really too much. In fact, I don't think you have to do any maintenance. I mean, things like brake pads that you might have to change after, I don't know, depends how you drive, but say 15 or 20,000 or whatever the number is, now can become 80,000 because you're using that regenerative power. And like I said, there is no oil and all that. So there is some fundamental advantages to the simplification of the drivetrain. I think that should make, once people understand it, those advantages will help sell electric cars. However, there's this whole thing about batteries, and not just the batteries themselves. The bigger part is probably the infrastructure that you need to charge the batteries. So if you're driving from Boston, say, to Baltimore, so you got New York City, you got Philadelphia, you got all in between, and imagine you're in a Tesla. There's so many supercharging stations between those in that corridor that it's not a problem. And the car will even tell you, hey, you're running low, you better stop in at this station over here. There's going to be 2 open slots, and in 20 minutes, you're on your way again. But what happens if you want to drive from Toronto, say, right, to Jackson, Mississippi, or Wyoming, a city in Wyoming, to the middle of Montana? Now it's a completely different thing. And I think that if you could solve that problem, people can understand the advantages of on the maintenance side. Well, then I think you'll have that customer demand that you're talking about there. But I don't know. Would you consider driving an electric car?
Well, it's funny, we had recently the F-150 Lightning that I booted around in for a little bit. And it was, a stupid amount of horsepower, stupid amount of torque. And again, you dial in the regen to maximum, and I didn't really hit the brakes. It just kind of slowed down. And so I guess, that maybe from my naive point of view, and I think a lot of car guys' naive point of view, don't really realize all of the advantages, like you're saying, that are starting to come, and maybe, increasingly will come with everything being electrified and not having way less fluids and oil products and maintenance potentially, I guess.
The other thing I think is, when I think about buying an electric car, and I think this is a consideration that most people would have to figure out if they'd want to do it, is I think, well, how many miles do I typically drive in a day? And especially if you're working remote, the number of times you might even drive 50 miles or 60, let's say 100 miles in a day is probably rare, I would think. But then maybe once a month or 2 times a month, you want to drive 200 miles, or you want to drive, well, now suddenly you've got that problem, right, of not having the infrastructure needed to charge it. So for those situations, hey, well, maybe you have an EV, but then you keep one internal combustion engine car for those long trips, right? I mean, the other thing too is, I think, and is like I race go-karts, so I have a go-kart trailer, and actually the tracks where we race are, I don't know, a couple hours away. When you pull a trailer with that Lightning or any truck, the mileage goes down, and suddenly a truck, a pickup, just, so it's advertised at 400 or 300 mile range. Now suddenly it's 100, right? So what are you going to do? And I think that's the problem that needs to be solved. There's probably different ways you could solve that. One of them being, well, just keep one internal combustion engine car if you could afford it. Maybe it's an older used one or something like that. But it's for day to day. Why not? Why not?
Sure. And but I guess the issue there seems like that's kind of, an upper middle class at least solution, to have two cars. Whereas
Right.
if you're just going to have one car, and you are going to make the odd big trip, or you're going to tow something every once in a while, it's not a solution yet.
Right. And so you have to think, well, how else can you solve that problem, right? The occasional trip where you have more more mileage. And one thought on that is right now the market is driving these cars to have 300, 400. Oh, we have 500. It's going up there. It's starting to get to numbers like that. Now, in order to have 400 or 500 mile range on an electric car, you got to put a lot of batteries in it. Well, but I'm only driving 60 miles every day. I'm carrying around hundreds and hundreds of pounds of batteries and just moving them around for no reason. And you can make the car as lightweight as you want, but if you're carrying those extra batteries, it doesn't make sense. It might make sense to say, well, what if the car only had 100-mile range on the batteries and it had a small motor, a range extender. In fact, the i3, the BMW, when they made an i3, they had a range extender on it. And day-to-day driving in the city, accelerating and decelerating, you would use the batteries. But when you get on the highway and you're going to run for 3 hours, you really just have to overcome the air resistance and the rolling resistance. Not that much horsepower compared to accelerating and decelerating. That's when your range extender could kick in. Now, if you think about that to solve the problem you talked about, first of all, if you only need 100-mile range instead of 400, you have quarter as many batteries, say, right, or third, whatever the number might be. That's going to bring the cost of the vehicle down. It's not a pure electric anymore, but if more people could start buying them, and if most of the time they're only driving 60 miles or 100 miles, whatever per day, most of the time they're going to be on electric power. So you probably start achieving some of the goals that you want from a sustainability standpoint, from a pricing standpoint, because if you can't get the price down and solve that range anxiety, you're not going to get people using electric cars. So that could be another way to solve it. But the market seems to be, everyone's competing now, it seems like, to have the most range, right? That's a big feature. It's almost like horsepower used to be. Now range is a feature everyone looks at.
Right. So, and then I guess the other issue that you talked about or touched on was the charging stations, and then the infrastructure, and then even behind that, I guess, is where is that power coming from? Can these electrical grids support, the vast increase in electric vehicles that these types of government programs are talking about?
Yeah. Well, yeah, there's the distribution of the power that you're talking about there. And then there's the peaks and valleys of when power is needed. You hear even now, even without electric vehicles, like it's a super hot summer day and everyone's turning their air conditioner on or whatever. And if you can level that out, then it puts less stress on the grid and all those types of things. Now, in some ways, electric cars help that a little bit, right? Because they're sitting at home in the evening, say, and charging when there's less demand, right? And during the day, when they're actually drawing on the batteries and everyone's running their air conditioners, they're sort of on the other side of the cycle. And in fact, I believe it was here in Massachusetts, I just heard this week, that one of the towns in Massachusetts was converting their school bus fleet, to completely electric. So you've got, dozens and dozens of buses converting electric, but they're just sitting around in the summertime. And one of the things they were going to do in the summer was actually use these batteries to store electricity for the grid, so that they could actually draw on that when there's peak times. So you could charge up the batteries at non-peak times and then draw on them when there is peak demand. So, yeah, I think I think you're absolutely right, though. When do you charge them and how much are you drawing from the grid? When you charge them is a different time than when you actually use it. And it might be that most of the charging is going to occur when others, like at night, probably when you're not drawing as much for things like hot air conditioning during the middle of an August day, say. So it helps level it out to some extent.
Right. The other, yeah. And I mean, I don't think these are unsolvable problems by any means. I think, a lot of the people who are opposed to it are more looking at the maybe unrealistic timelines that are kind of being banded around before big, slow-moving changes can be made, in infrastructure. I guess the other hot button issue right now with electrification and these huge increase in battery production is the mining of cobalt. And, I guess lots of journalists kind of looking at, really how ethical are these mines being run, and China owns these mines, and it seems like a serious quagmire.
Yeah, well, you're talking about something that's really important to consider, especially when you think about sustainability, too, because a lot of energy goes into doing all this mining, and when at time zero, if you compare an internal combustion engine car to an electric car, the electric car is actually behind from a sustainability standpoint because of all the energy that was required to mine the materials and to actually get the batteries to where they are. And then, okay, but if you assume that you've got clean energy, which is solar power or hydropower, whatever it might be, and there's a small number of batteries in the car, say the range is only a couple of 100 miles, the crossover point where the electric car is doing less emissions, because when it's running, the emissions have gone to zero if it's clean power, might be, I don't know, 15, 20,000 miles, something like that. But if you put, a lot of batteries in there and you're running it from a power plant that's run on coal, that number starts to move out. So, yeah, I mean, of course, you have to also think at the same time that battery technology is changing, right? And so it might be different 5 or 10 years from now. It's a direction you have to head in, but you also have to figure out how to solve some of the problems that you're solving here. I think a lot of the time people just don't like change, and the automotive industry has got great examples of that, like seatbelts. I don't think the automotive industry wanted to put seatbelts in cars or airbags or have fuel economy standards, right? But in the end, it was probably good for everyone. But you're right, it's not going to happen overnight, and there's going to be resistance. But I guess time will tell. But you do have to address all these other issues that you have. You're changing not just the cars, but the infrastructure and how you build them and design them, and like you were saying, how you mine the materials. You got to look at the entire supply chain. In fact, some of the legislation that's just coming out now, which is to provide, rebates or whatever you want to call them, if a certain portion of that vehicle is manufactured or mined within, the United States. That's all part of starting to look at some of these issues that you're talking about here.
Right. Is there technology, is it moving in the direction that you can use less cobalt or even different materials to help alleviate some of those problems?
Yeah, that's always the goal, right? So there's solid state batteries that have the potential of giving cars much greater mileage. They have other issues in terms of keeping them safe, that type of thing. You'll probably see batteries like that first in cell phones and other applications, and eventually in cars. I mean, you can substitute in different materials like lithium. Lithium is a great material, but it's you could do the same thing potentially with sodium, but now the batteries get heavier. It's materials engineering is pretty key, I think, and there's a lot of startups, a lot of large car companies, a lot of money being put into figuring out how to sort through all the potential options.
Right. In your eyes, is it like is it will it for the sustainability push, will it be electric or bust, or are there other options that will be entertained as far as hybrids or hydrogen or whatever it may be?
You know, I think it should be a mix. To say on X date everything has to be a battery electric car, is that really what you want? What you really want, if your goal is sustainability, is you want by a certain date, and it could be 2030 or 2040, I don't care how you do it, but your vehicle has to be X amount of emissions, no emissions or whatever. So you could run hydrogen in an internal combustion engine that has water as exhaust. Right now, of course, hydrogen has its problems with infrastructure and keeping the tank safe. And also with hydrogen, when you use hydrogen, an interesting problem with that is the volume that it takes to store all the hydrogen you need in a vehicle. It starts to take up a lot of space. You think you got a problem with batteries taking in packaging a vehicle. With hydrogen, it's actually even harder. But it could be that. It could be that. The other thing is sometimes I wonder, like, how did they pick 2035 or 2040 or whatever, and to say it's zero? Or could you, like, for instance, e-fuels is an example, and Siemens actually does some work in this area. They did a project with Porsche in Chile, and what this did is they had these wind turbines on the mountains in Chile that would create clean energy. Then they would scrub CO2 out of the atmosphere, right? So now you've got CO2 being scrubbed, so you're pulling CO2 out. Then they would use the wind turbines to run electrolysis machines. And electrolysis machines converts water into hydrogen. Then they combine the hydrogen with the CO2 that they scrubbed out of the atmosphere, combine that together, and they make, I believe it was methanol, which eventually gets converted into gasoline. So now you have this gasoline that is actually taking the carbon out of the air. So it wasn't made from fossil fuels. It was made from carbon in the air and hydrogen that was created from a green source. And then Porsche takes this fuel and they run it in their Porsche Experience Centers so that when you're out there driving on the Porsche Experience Center, you're not adding to the carbon. In a way, you're sort of moving it from Chile to somewhere else, but it's carbon neutral. So e-fuels is another way, I suppose, right? You could say. So I think sometimes you have to take the politics out of a lot of these things and say, what are you really trying to do? And if it's truly to remove carbon out of the air and do it as soon as you can, it has to be a mix of these things. And I think that's an important way to look at it, rather than saying, I'm for sustainability, so I want electric cars. You can say that. That's probably not untrue, but is that the fastest route to it?
Exactly. I think that should be more of the conversation. Politics gets so dumbed down and into talking points, but really looking at everything on a holistic level, it has to be net better, all the way down the line, and then that's a real solution, as opposed to just feel good solutions that are being bandied around and I guess along those lines, to me anyways, and maybe I've got the numbers wrong, the low-hanging fruit is not personal vehicles at all. It's just a bigger target than the transportation industry. Do you agree with that? Is the same thing happening on shipping, planes, tractor trailers on the road?
Well, I think you're right. The example we were just talking about before, school buses. And certainly semi trucks moving, it could be in some ways, just looking at this simply, if you're driving an Escalade into a city all by yourself, there's a lot of steel you're moving around for one person that weighs 150 pounds or whatever it is. So if you put 9 people in the Escalade, the cost to move someone, the amount of emissions per person to travel X miles goes way down. So certainly when you're moving goods or moving a lot of people in a bus, anything you could do on that, it makes them even a better choice. Or just using public transportation when it comes to sustainability is really good. I think, getting back to the towing of the trailer, right? Going long distances, that's when you start to have some problems by having to stuff so many batteries, say, to allow you to go, 20 or if it's an aircraft, right, 3,000 miles or something like that. So a lot of you see things like urban air taxis. People started talking about those. That's a great application for an electric drive in an air vehicle. It only has to go a few miles from downtown Manhattan, say, to LaGuardia Airport or something like that. However, to power a trans-Pacific or transatlantic airline or long distances with just batteries, I mean, you're going to have to fill the plane up with batteries, right? So for that, e-fuels or something like that might be a better approach. Or hydrogen. Hydrogen could potentially give you that kind of range. So yeah, it depends on your application.
Right. I always look at these, big shipping boats, and my cousin was in the Navy, and he was on a nuclear sub, and he, was talking about how incredible that machine was, and wondering if there's commercial applications for nuclear powered boats there.
Well, if you think about it, nuclear power from a sustainability standpoint, I don't know what you do with the remnants of the spent material and all that, but it's pretty clean. And it does solve that range problem. Nuclear submarine can stay under the water for months, I believe. You have to ask your cousin or whoever it was, but I mean,
yeah,
they could go many, 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 many thousands of miles. I don't know if you want to put a nuclear reactor in an airplane. That might be a problem, but nuclear power for power generation and all that, again, that has political implications as well as to what do you do with the spent fuel. But maybe if somebody figures out how to do nuclear fusion, then that problem will get solved too.
Yeah, that's what I always hope for. Yeah, someone figures that out. That's my solution anyways. That's where I'm putting my eggs. But moving to, I guess, autonomous vehicles, another whole can of worms. Where are we at right now, and when do we get to self-driving cars?
Again, that's a good question, and what does that really mean, when we get there? And I think that one of the things is to look at how we look at autonomous cars or how we perceive them. And there's this curve called the Gartner hype cycle. I don't know if you've ever heard of the Gartner hype cycle or not, but Gartner is this consulting company, and they've created this curve which describes how we react to technology when it's being introduced. And when technology first comes out, oh, wow, this is really cool. And it reaches what they call the peak of inflated expectations. This is going to save the world, like cold fusion or autonomous cars. Autonomous cars were at the peak of inflated, they're at the inflated expectation peak 2015, 2016, and then boom, something happens. Somebody has an accident, as you recall, or whatever it might be, and it goes in, and then suddenly it's like a cliff, and it just goes straight down, and it enters this thing called the trough of disillusionment. And then the curve, and this happens over a period, I would say for autonomous cars, it went from 2015, 2016, you're sitting at the peak. By 2019, 2020, certainly where we are now, you're sitting at the low point. Well, suddenly, I give up. This is never going to work. But almost most products go through this cycle. And now is when the hard work starts to eventually, and this could be 10 years or 15, it depends. And one of the things it depends on is, well, what's the application? If you wanted to do everything a human can do, and let's race a car on a road course in Formula One. I don't know if you can do that in 100 years, right? There's all sorts of strategy that the thing has to do besides know where the other cars are that are around it. Okay, well, let's make it really simple. All we wanted to do is go from Terminal A to Terminal B on a well-marked lane at Logan Airport here in Boston. And no other cars are going to be allowed to go in that lane. And we're going to only operate it on a perfectly sunny day during the day when you can see all the lines. Oh, well, an autonomous car can probably do that today. And there are autonomous cars that are starting to do that kind of thing. And there's these different levels of autonomy. And when you get to, there's 5 levels. Level 5 would be full autonomy. Level 4 is full autonomy within a constrained area, like the example that I just gave. And there are places right now where autonomous cars are doing that. So I think that when will they be here? Well, they're here now for certain applications, but then you need infrastructure, to handle those and to operate them and all that. But, over time, that operating environment will grow and grow and grow. Will it ever have to be that it does everything that a human does? I don't know. I don't know if that's maybe it can eventually, but they can certainly be useful before they do that. And I think probably one of the interesting applications for this would be what you might think of as a guardian angel, which it's an autonomous system and it's sitting there watching you. And then suddenly you're doing something really stupid. I can't believe this guy's trying to pass this guy here, or whatever it might be. And it steps in and maybe applies the brakes a little bit or something to slow you down so that the car doesn't spin around or who knows what. But, and we had a project that we did for the FIA in Raleigh where we took autonomous car sensors and put them into rally cars. It was the radars and the LiDARs and the cameras. We looked at, it was just a conceptual study, but we looked at using simulation, could you detect spectators? That in rally, spectators like to jump out. I mean, they like have their hands sticking out with their cell phones trying to take a picture of a rally car that's like 10 feet away. But there's a great application of autonomous car technology. It's not really controlling the car, but you're using pretty much everything you would do to detect what's going on in the environment around it to take action. In this case, the action is not to control the steering wheel, but to call some of the people that are, at the track there that are tell you, hey, get away from there. You're not supposed to be standing out there, that kind of thing. But yeah, it's the question everybody asks. When are they going to be here? When can I go to a dealership and buy an autonomous car and drive it around? I don't know. I think that's a long, long ways away. Because if you're going to do that, that means that you're taking that car home and you can use it anywhere you want, anytime, snow, rain, whatever it might be. When we're working with the rally people, the interesting about rally is when you're on a road course with pavement, you worry a little bit about, it's a 50-degree day or it's a 90-degree day, up on the tire pressure a little bit. You make some adjustments and all that. But then you're roughly in the ballpark of what that track is what you need to do to make that car operate on that racetrack. Well, imagine if your racetrack or your track, in the case of rally called a stage, can go from pavement in one area and then suddenly it's mud. They have 4 classifications for mud. I think it's 4 in rally. So like gooey mud, I guess, or not so gooey, or semi-firm mud. And they'll do a run in the morning and they'll go through, right, on a shakedown run, and they get an idea of what it's like. But now the sun comes out. Was that little section in shade or was it in the sun? Did it go from mud type 1 to 2, which has different kinds of traction? Well, the driver has to feel that and say, oh, it is type 2 mud or whatever it might be, right? Or there's some gravel here that we didn't expect to see. And the same thing could be for an autonomous car, say on the road. You could have cameras and everything looking at what the conditions are or whatever it might be, but there's this thing called black ice. You can't really see it. It's just, and suddenly, I have no traction. You didn't see it, you felt it, and then you knew what to do. I don't know, could an autonomous car do that? I don't know. And if you're just going to buy one on the lot and take it out and drive it around, humans at their extremes can do that. So anyways, I think, again, going back to your question, which is when will they be here? If here to you means when can I go to the dealership and have it drive me home, right? And then drive my kids to school the next day, that's far away. When will you be able to use an autonomous car in some sort of a productive way? It's probably not that far away. Could be within the next 5 years. And in fact, in some cities, you could do it now.
Right. In my limited view, looking at applications for autonomous vehicles, the one that jumps out to me is like, farm tractors or something like that, or dozers with GPS, and those things can kind of just run themselves across the Midwest without anyone in there.
That is a perfect example of this constrained environment. On my podcast, on the Future Car podcast, I had Carlo Mondavi. He's a grandson of Robert Mondavi, which is the big winemaker from Napa Valley. And he started a company called Monarch Tractor, which is autonomous tractors. And basically, they go down the rows in the vineyard, and they'll do things like spray chemicals or whatever. And one operator can operate 8 of these machines at once. So his goal was always to be more sustainable. And so he was coming up with all these organic chemicals and things to spray the vines, right? And then finally, his fellow vintners said, "Hey, you're really doing great things for the environment with all these organic chemicals, but because they're organic, they're not as effective. So you got to spray them more often." So now he's running these diesel tractors all the time, and he's actually hurting the environment overall. So he said, "Well, I'm going to go to electric." Well, okay, so now you go to electric. Now you've got the cost of the batteries and the charging system, because these things are going to be running all the time. And then he said, "Oh, but if we make them autonomous and electric, we could run around the clock even. You could even run at night because they're quiet. They don't make any sound. And if I have one operator running 8 of these, now my labor costs and all that actually go down." And I think farming could be a vineyard, could be corn harvesting, whatever it might be. Mining would be another, where you've got a very fixed set of roads. And it could even be what you might consider like platooning. And they talk a lot about this even for autonomous vehicles, trucks on the highway, where the front truck or the front tractor, say, is driven by a human, and the other 8 or whatever sort of follow. And if you turn, there probably could be some algorithm there, but in the case of the platooning autonomous trucks, the front one is the human making all the high-level decisions, and the rest of them just follow in a line. It's almost like a train on the highway, you could think of it.
Right. Yeah, and I guess big cross-country trips with, on major routes, that falls more into your category 4 kind of more constrained environment, I guess.
Right. Yeah, exactly. Especially if you give it a lane all to itself, say, something like that. If you think you can, afford to do that, you got the room.
Sure. To me, the big change comes in, and I don't even really know how to conceptualize it, but whenever the AI really kind of comes online, is that something that's in the forefront of your mind, or is it something that you guys are even working on? Is artificial intelligence integration into this stuff?
Yeah, I mean, artificial intelligence is certainly part of any autonomous car, because it is going to be making decisions. It is going to be learning. So yes, the answer to that is yes. I think an interesting thing is that if you've got hundreds of these, or thousands, many thousands of these autonomous cars running out there, and data is being collected from all of them, all the cars learn from all the other cars. So it's almost like you can, the speed at which they'll improve probably goes up very, very quickly compared to how quickly a human driver might learn. So the ability to learn, right, is really important. And the ability to collect information on why accidents happen or whatever, all that's going to become, and even for, I guess that'll even happen for human-driven cars. But the ability then to collect that information and put it back out there in a form of an improved program that utilizes AI to control these vehicles, I think is going to be important. The other thing I think, too, is the infrastructure. We talked about charging infrastructure, but there's also another level of infrastructure is having an autonomous car communicate with a traffic light, say, which now starts to allow it to look around corners even. So you're approaching a corner and you could tell, hey, it's no use going 30, might as well slow down to 20 because you're not going to make this. Or it could be smart enough, the intersection could be smart enough to know that, between 2 and 2:30, everybody comes out of the courthouse and this intersection is going to be jam-packed. Let's reroute everyone just for the next 20 minutes this way or that way. And, if you can keep these cars moving, even if they were internal combustion engine cars, that all helps when you're concerned about sustainability and fuel efficiency and those types of things. And with an autonomous car, those kinds of commands, and it actually goes both ways, right? All these cars that are out there are actually telling the infrastructure what's going on. And now AI comes in there, as you're saying, or some high-level reasoning because it's not necessarily a simple problem, right? You've got all these things moving in all sorts of different directions and things happening that are not related to the cars themselves. You got to figure out the best way to handle all of those and send new commands to these vehicles to take best advantage. And what does best advantage even mean? Is it emissions? Is it efficiency? Is it a combination? Right? So I think this is all going back to, cars are not just cars anymore. Especially once they become autonomous, the word is living room on wheels. So we're talking about it moving around, but the whole time you want to also be entertained, probably be watching movies or who knows what, shopping, while you're in there or whatever. There's a lot that can happen here, and I think it's going to force different groups that normally don't work together. Certainly engineers that make batteries and car bodies, but now we're talking about people that design streets have to work with the people that are designing cars. And this is from a physical standpoint too. What do we do with the lanes? Do we put more lanes in or less, or different size lanes? And if you consider that while you're doing design, it can also help with efficiency, all that. And I think, one thing we haven't really touched on, we think of cars, a sedan or a compact car or a SUV, but what about a scooter or a one-man electric car or two-man electric car, whatever it might be, a two-person car? And let's say you limit them to 25 miles per hour and you say, we're going to make a really thin lane for them. And now I can get 2 lanes in where I used to have, one or whatever it might be. And if they're autonomous, they can actually run closer together, right? Because all the cars are talking to each other. You don't have to leave that braking distance in between. So now you make the roads even more efficient. So there's a lot of things that can start to change when AI comes in. And really just this control system and communication between all the moving pieces, especially if you consider how to use all that capability with the physical world and how to redesign your lanes and your streets and all that. And then again, there's always if these cars are always running and they can run on their own, who needs parking? What are you going to do with all those parking garages and things like that? So you're going to have an opportunity to redesign cities here.
Yeah, it's interesting. To me, it becomes, especially in a place like the States, I'm sure everyone sees it as this double-edged sword, as technology has been, so many more efficiencies afforded to us, but it always seems to be at the expense of personal autonomy or what happens to the person who doesn't want to go along with this in the smart city, who's driving their 1990 F-150 and they're jammed in the middle of this. Like, I think things will have to move a lot slower if we're going to maintain a lot of our freedoms.
Yeah. I was thinking, so I mentioned that I have an S2000. It's an older car, but it's almost an S2000, the Honda S2000. It's almost like a go-kart. It is. I mean, it's got this roaring engine, that goes at 9,000 RPM and all this kind of thing, convertible. And I drive it to work at 5 miles per hour because I'm stuck in a traffic jam for 20 minutes. Or half an hour. How much fun is that? And then I drive it into downtown Boston. I'm worried somebody's going to scratch it or dent it or something like that. On the other hand, it's great to take it on that winding, twisting road, tops down, wind in your hair. Now you're enjoying the car. I think, and your F-150 too, you've got that F-150, you're putting your tools in there, you're going to work or whatever it is you're doing with it, towing your boat or your and all that. But you know what? And I have a pickup truck too. It's not an F-150, but if I take that pickup truck, I never take the pickup truck in Boston. And I'll tell you what, if I could drive my pickup truck to the edge of Boston and I could jump into a 2-person little electric pod thing that I can pick up at the parking lot on the edge of the city and drive anywhere I want. And since it's so small, you could probably park it at 90 degrees of the curb and there's parking everywhere. I'm going into Boston not to have fun driving my sports car around at high speed. I just want to go in there to go to a restaurant or whatever it might be, right? So sometimes I think about horses, right? There's nothing but horses around for transportation, and now cars have taken over, but you still have horses. And people that really enjoy horses go to tracks and stables and ride them. And that's probably what's going to happen here, I think, over time, is that people that like to race or people that really like to drive are going to find ways to do that because it's fun. But it's not fun when you got a really fancy car and you're going 5 miles an hour in a traffic jam, right?
Yeah, it's funny. I might be more receptive to this than most car guys, being a race car driver, because I don't get a lot of my driving kicks on the street, if at all. I drive around in my pickup truck and I'm listening to an audiobook or a podcast or whatever, and I'm just getting from A to B. And I get my fun at the racetrack. Yeah, exactly right.
Yeah, but there is something to the car and the image it provides you. Right? Well, I'm a pickup truck person, or I'm a, I don't know, I'm a Prius driver, right? That says that's a statement there too. And there's a million other ones. And now that's what cars do. Will that continue, 2 generations from now? I don't know. Will people really care? They do now. And in part, I think what you're talking about is that problem. It's not even a problem. It's just the way things are. And I think your point is a good one, is that if there's going to be little electric cars buzzing around in a city or whatever, autonomous vehicles, what about those people that want to be in the city to show that their image is the pickup truck person or whatever it is? I don't know. Yeah, it's an interesting thing. I was talking with Bob Bell. He's he was a technical director for Mercedes, also for Renault, right? Formula One teams. And we were talking about the electrification of Formula One. And not necessarily electrification, but really in 2030, they could be net zero. So they want these cars to could be electric, could be hydrogen. Who knows what's going to be? And I said to Bob, well, come on, Bob. What about the diehard fan that loves the roar of the engine and the smell of the gasoline? And what about those people? And he said, well, I don't know. He says, pretty soon they're all going to be dead. He said, that was his response. So over time, there's going to be a change in what's important to people. Because we've been around and we're, we like to race and drive. I mean, the smell of the brake pads and the engines and all that kind of, it's exciting. And we're always going to think that that's exciting. And I think there are always going to be some people that think that's exciting, but over time, the percentage of people that think that's exciting is going to go down. And you're already starting to see a little bit of that change. But I think that you have to have the capability for a while, for a long time. I think you're still going to have this freedom of choice to pick whichever one is best suited for you. I don't think there's anyone talking about outlawing completely internal combustion engine cars. I mean, they are talking about not allowing or setting some numbers for what fuel economy levels should be. But as long as they can achieve those, I think even some of these new regulations that just came out, if you can figure out how to get your overall fleet to a certain level, which could include internal combustion engines, you're able to do that. It is driving you a lot to battery electric or hydrogen or whatever it might be. But
Right.
but I think I don't know. You're going to see some. No, go ahead.
Well, I was gonna change gears a little bit. While you're mentioning F1, you get such an insight into the garage area and the paddock area, and I guess the FIA clearly working with them. What happens to F1 to push you on that? Do they go electric? Will the combustion engine go away with this 2030 mandate for them to be net zero?
Well, actually, in that same conversation with Bob Bell, one of the things he said is, well, what if we run hydrogen in an internal combustion engine?
Mm-hmm.
Clean and very loud. Now, you got other problems on how you got to get those hydrogen tanks to withstand a crash. And it's not to, in the, the technology is probably there, I would imagine. I don't know. But I think the goal is not to say, I don't think anybody knows what it's going to be. Is it going to be battery electric? Is it going to be hydrogen with a fuel cell, right, which would also have batteries? Or is it going to be hydrogen running an internal combustion engine? Might it be a hybrid of some kind? In the end, you got to make the product marketable. Racing is a marketing business. It's sponsors and you get sponsors if you win, and it doesn't matter if you win if nobody's in the stands, right? So and certainly if no one's watching, on TV or whatever it is, and so in order to do that, they have to, when Formula One, what was it? I don't know, it's been a while now, but between 5 and 10 years ago, they switched engines, and they had those shrill, it hurt your ears, and they went to more conventional sounding. And, everyone was complaining. This isn't Formula One anymore. Now it's long forgotten, right? It's long forgotten. But I think if they had no noise, it might be different. I don't know. It's like Formula E.
Yeah, I mean, I look at Formula E, and then I've watched only the highlights a handful of times, compared to pretty religiously knowing what's going on with Formula One. So yeah, it doesn't have the same appeal for me there, definitely. Are you a fan of any team? Are you allowed to be a fan of any team or driver?
In Formula One, or?
Yeah.
Well, like I mentioned earlier, since we were a startup, we worked when they went from Benetton to Lotus to Renault to then Alpine, and I have a lot of friends there. In fact, being in Boston, when they come to the race in Montreal, which is not too far away, afterwards, a couple of them will come down to our house here in Boston, and we'll, hang out together. But so certainly Alpine is a favorite. We also sponsor Red Bull. They use our software, so certainly got to root for them as well. My parents were both from Italy, so they were immigrants from Italy. So there's always a love for Ferrari, of course, right? If you grow up in an Italian family, you gotta love Ferrari.
Yeah.
But these days, it seems like it's Red Bull all the way. So I don't know. How about you? Do you have a favorite?
For F1, I mean, I'm a Verstappen fan. I think ever since kind of seeing him come on the scene when he was 17 or 18, and seeing some of those performances, especially in the rain when he was really just a kid, and he made everyone look like idiots out there a couple times in the rain. It was like, oh, this guy is the real deal, whatever you put him in.
Yeah, well, he's definitely proving that. That's for sure.
Yeah. What do you guys use Formula One at all as kind of proving grounds for some of your technology? Is that still the case? I mean, that was always the thesis, right? Is racing is where we test all the stuff and then it can go to production cars. Is it still like that a little bit?
Oh, absolutely. Absolutely. And you know, there's so many things that have been invented in racing, right? That ended up in cars. And our business being engineering software, let's compare an aerospace company to a Formula One company. So an airplane, let's make a new airliner. Well, it's going to take 3, 4, 5 years before what you have on that CAD screen, right? What you have on the design screen is going to actually become something real. In Formula One, you know, every 4 years is a complete rules change. Every year they're designing a new car, and every couple of weeks you might have to lay up a new front wing or who knows what, right? That's a different configuration. So the ability to go from analyzing, we were talking about that digital twin, right? Analyzing it, making sure it's going to give you the strength, the stiffness, the ability to perform at different temperatures or whatever. You're figuring all that out electronically. Okay, so now I know what the design is. And since it's carbon fiber, now I got to figure out a monocoque. I don't know, it has hundreds and hundreds of little pieces of carbon fiber that have to get laid up. They can be very, very thick, you know, well over an inch thick in many, many areas. So it's like many, many layers. You got to take all those pieces, figure out their shape, cut them out, and now you have to give instructions to the floor, you know. So over the years, although we didn't sell, you don't sell as much to the Formula One teams because the market is very tiny. Right? There's not many companies that are in Formula One. However, we learned very quickly to develop strong partnerships with them. First of all, it's a lot of fun to go to a Formula One factory and just hang out with them and just, you know. But more importantly, from a business standpoint, we would work with them hand in hand, and we would always say, "Tell us what your problems are." And you know, if you're going to make software, engineering software, and we use composites as an example, the best way to know what to put into the software is to go in the lamination room and put on, you know, the white jacket and a little hair thing, right? And go in there and watch them lay up, or even try it and do it, right? Because I don't know if you've ever seen people lay up carbon fiber before, but it's part art, it is part science. You know, if you have a very complex shape, and a wing is a great example of that. If you have a very complex shape, depending on where you first put the material down and in what direction you sort of push it, will change where the wrinkles are or the orientation of the fibers. If you change the orientation of the fibers, the stiffness is along the fiber direction. So how do you make sure everybody does it the same? We solved those problems initially with Formula One teams, not in the aerospace industry, because they would know if they designed it on Monday, laid it up on Thursday, drove it on Friday, Saturday, and Sunday or whatever, right? They could give us feedback a lot sooner than would you have a much longer design cycle. So yes, absolutely. And plus, it's like I said, it's fun to work with them, right? It's always fun to work in an energetic, fast-moving environment.
For sure, there's nothing like intense competition to drive progress for sure. I guess going back to the AI, or what I conceptualize as the AI really coming online and being this kind of master system. How does that, when do you think, or what are the implications of when the AI system can take the rule book and design the perfect car, and when, you know, it'll be good enough that every team shows up now to the beginning of the year who all have the same AI system and they all show up with the same car, you know, and with the same setup, and now it's just driving.
Wow. You know, God, there's so many aspects to answer that question. It's a great question. Have you heard about Chat GPT? Have you heard about that?
Of course, I use it all the time now.
Yeah, so do I. It's great. Who would have thought a year ago that you could ask this thing to talk to you and give you information? I use it all the time. Um, when it came out in November of last year, and I was getting ready actually for an interview I was going to do with Mario Andretti. And I saw this thing, and I had already generated a set of questions. I said, what questions would you ask Mario Andretti? And it generated like 10 questions. 8 of them I'd already done. 2 I had not thought of. Like, oh, wow, those are really good questions. Then I asked it questions about the questions. And next thing you know, I had a bunch of new questions. But then I said, hey, what would Mario Andretti and AJ Foyt say if they talked to each other about who the greatest race car driver of all time was? And I'll tell you what, it created this conversation. I couldn't believe it. This is only the second or third time I'd used it, right after Thanksgiving when the thing had just come out. I sent it to my friends in Indianapolis. And I said, hey, check this out. A computer created this. And one of them said, ooh, that's creepy. It's like, oh, wow, AI is that smart. So the point I'm trying to make is that over a period of a year, suddenly AI is helping us do writing. It's helping us create these things that look very, very creative. You know what? It does things that are a little crazy, but if you know how to use it and use it properly, it can save you a lot of time and get you a lot of useful information. Now, designing a vehicle or car, or especially a race car, which is the highest levels of performance, it's not just being able to go out and search, right, and find a bunch of stuff and collect it. You have to make a lot of decisions based on that to figure out right materials or whatever, or even something as simple as where do you start the layup for composites so the fibers go. I would think eventually, why couldn't a computer start to access these other programs just like a human accesses programs when they do design and all that? But then, okay, and you did all the simulation and everything. Now you got to take this. Well, let's use racing as an example. So you take this race car you've designed, and of course the AI is running the factory, so it designs it, it builds it perfectly. Now you put it on the track. And as you know, when you start your season here in a month or whenever it is, and you take that car out for the first time, you'll do a couple of laps and you come in, you're going to tell everybody everything that's wrong with it. And say, tweak this, tweak that. I think this and that. Well, it's a little cold today, so don't worry about that. But I think when it gets warmer, on and on and on. It's based on a lot of experience. That some is just like a feel or something. God, I don't know when a computer is going to be able to do that, right?
Right.
Yeah, I don't know. I think we're way far away. But in the long run, though, this whole idea of along the theme of racing, I mean, who really wants to watch a bunch of autonomous cars, a bunch of computers racing around an oval? I don't know. It's all about the drivers, isn't it? I mean, Drive to Survive, that Netflix series, has proven that with Formula One. So
yeah, I look at that because I talk about it with my cousins, who are some guys are on my pit crew as well, and we, after the race, we talk about this kind of stuff, and there's two kind of implications of it. One, I think a lot of people watch NASCAR and Formula One for the engineering and what did the team come out with this year, and which crew chief won the guy the race, or yada yada yada, and that's one aspect. But then if you do have this AI and everyone has the same AI and every car is theoretically perfect for each condition, now it is just the drivers. Now it is a pure competition between the skill of the drivers. You know what I mean? So it's there's kind of two ways to look at it, pluses and minuses on both sides.
Well, if you take a race car from, I don't know, pick any year you want, like 1980 or whatever, and simple car in many, many ways, no traction control, not just motor, brakes, tires. And you put a skilled driver in there, one driver will be better than the next. Now, all of a sudden, you can add whatever you want to it. Traction control, anti-lock braking, wings, keep going and going to your AI assistant, right? Well, the best driver is going to figure out a way to get the most out of that. And I think ChatGPT is a great example of this. If you just tell it, write a term paper for me about, the history of Formula One, all right, now if I just turn that in, pretty soon everyone's going to be doing that. And here's a Chat GPT Formula One paper. It looks almost like that other guy's over there. But if you, and the example on the questions that I try to generate for a podcast, well, I'll generate 10 good ones for me. I'd already thought up 8 of them. Ooh, but those last 2 are interesting. I'm going to dig into those, and you do several rounds with it. Next thing you know, you have something that you couldn't have done on your own. But it's not that Chat GPT did it all, just helped you do it faster. And I think it's probably the same when you have that super AI car. And I wonder, maybe that's what it will be like in 50 years. There'll be these super machines, but somehow the creativity of the human driver. In fact, it's funny, right? If you think about that 1980s race car, it's like you're driving it by the seat of your pants, heel and toe, whatever it is. It's all real. In some ways, it's complex, but in some ways, it's really simple. Well, now, if you look at the steering wheel in an F1 car with all these buttons and readouts, and they're sitting there and playing with them, and DRS and this and that, well, you don't have to heel and toe. It's paddle shifting. Now you don't have to worry about the clutch and all that kind of thing. Well, it's easier in that respect. But if I don't know how to play with those buttons in just the right way based on the conditions and when I want to make the pass and all that, it's another skill. But it's a layering on, you have to do that while you're still going 200 miles an hour. And, you know what it's like. There's so many things you got to think about. Well, I'm going to give you 10 more things to think about. I'll take away these 3. Is it harder? Oh, maybe in some ways. A bit easier in others. The AI thing is just going to force the driver to think of even higher level things, I guess.
Yeah, no, and that's a great example with Chat GPT. I think people who haven't really used it, there's a total skill behind, eliciting good responses from it. Yeah. I don't want to keep you too much longer. A more general question, and I think I know the answer probably, but are you pessimistic or optimistic about the future as far as our technological advancement and all of those implications?
What do you think I'm going to say?
You're optimistic.
Oh, yeah. You have to be, right? You have to be. Yeah. But it is challenging, right? You have to figure out how to, work your way through it. New technology always can be scary. It goes back to the peak of inflated expectations and the trough of disillusionment. Right? So you're always going to go through that, but you come out of the trough, right? And you might come out of it in different ways, but it's exciting. You don't know what the outcome's going to be, but you have to be accepting of it and make the most of it. And I think this little conversation we had on the side here about ChatGPT is one great example about it. Yeah, I mean, you could be negative and say, it gives you bad answers sometimes, or, it's going to eliminate jobs of writers. Or you can say, wow, if people can learn how to use this, they're going to become better writers. But I think that it's challenging. You can't be lazy. Right? You can't be lazy. You can't be happy with the status quo, right?
For sure. Slightly off topic. What kind of stuff are you? I mean, you seem like an interested guy, which makes you an interesting guy. What's kind of lighting you on fire these days? What are you interested in? What are you reading outside of your field?
Oh gosh. Well, I'll tell you what. What's well, first of all, just like for hobbies and things like that, certainly go-kart racing is, now that we're getting into the warmer season, but in the wintertime, spend a lot of time snowboarding. Let's see, what else? I actually have a little vineyard in the backyard, so I grow grapes and make wine and stuff like that. So it's sort of a variety. Still play guitar and do all those kinds of things. When it comes to reading, I'm actually, lately, I don't know why, but I got on this thing where I'm reading these books about as we age, you get old, and you're going to someday, can you live to 100 or can you live to 150 or 130? What keeps us from getting older? But more importantly is, if you get older, why is it that someone that's 100 years old can't go snowboarding down, a Kalur in Montana or something like that. And what does it really take to do that? I don't know. So I've been reading some books about that, which I think is sort of interesting, where they don't look at aging as inevitable, but more as a disease that maybe could be cured. I guess that raises a whole set of new problems too. But I've been reading some books about that. But I don't know. I read a lot of different types of books. It's just I got mostly audible books, right? Where audiobooks. And so I'll say, what am I going to read next? And I just look at what pops up, and I'll just pick one.
Right. No, that's great. No, I'm a big mountain skier as well. I ski out west all the winter, as I can anyways. Yeah.
Did you go this year? Because a lot of snow out there this year.
Yeah, well, a lot of snow down in California, that's for sure. We caught a little bit of good snow out in British Columbia, so we went out there. I've got a little guy now, 6-month-old, so it, cut our winter short certainly, but we got out for 2 weeks.
Oh, that's great, and that's a lot of good powder up there. That's for sure.
Yeah, absolutely. Huh. So the final question I have for you, for a lot of my younger listeners and maybe even just older guys, what advice do you have for people professionally who want to pursue their passion?
I'll give 2 pieces of advice. First of all, you better make sure your passion can make you money so that you can survive. It's great to have a passion, and if you really want to do it and you don't care about having a lot of money so that you can have everything you want, it's okay as long as you're going to be happy. So you just have to consider that a little bit. The other thing, which I think is probably you'll face it more often, is sometimes the path to your passion is not direct. Like when I was first out of school, I was working Detroit Diesel Allison, working on mining trucks and stuff. So it's somewhat automotive. Next thing you know, I'm working on robots to make clothes. But if you're always keeping in the back of your head, I'm gathering some skills that are going to be useful in one way or another. Hey, eventually I'm working on rally cars and F1 cars again. So you can't be afraid to pivot. Sometimes the path is not direct, especially if you truly, truly want to go after your passion.
Right. No, those are some great answers. I'm a big fan of the first one. You don't want to go broke if that's not your intention.
Yeah, exactly. But if you don't care about being broke and you're happy, I don't know how many people actually like that, but it's probably gray, right? There's something in between.
Absolutely. Well, I appreciate your time, Ed. This is it's been a lot of fun, and we'll do it again maybe in a year's time or sometime.
Sounds great. We'll see where those autonomous cars are then. Probably not on the racetrack.
No, I hope not. Anyways.
Yeah, I doubt it. Hey, thank you so much. It was great fun.
All right, take care. See you guys next week.